Well, hello everybody, and welcome to the the October, the October edition of Web Zurich. I'm jumping ahead a little bit. Tomorrow is November, right? That's good. It's Halloween, Spooktober. Today we have 2 or 3 fantastic talks for you prepared. But before we jump into them, I'd like to say a few words about Web Zurich. For those of you who are just joining the live stream right now, feel free to add something in the chat. Say hi, say where you're from, if you're a developer, if you're a designer, if you're doing something completely different. And also, if you're watching this later on, if you're watching the recording, feel free to comment and leave us a few comments if you like, or just like the video if, well, you like it. Excellent. I'm really looking forward to hear from where all over the world people are joining our lovely little meetup here. One of the upsides of this meetup being a virtual one and being online is that you can all chime in as you wish. So again, feel free to use the chat. Say hi, say what you're up to, where you're from, what kind of background you've got, and we'll see if we can span across the world in this lovely meetup. For those of you who are seeing this meetup for the very first time, you can also tell us if you're here for the first time or if you have been to previous editions of Web Zurich. Just out of curiosity, would be kind of interesting. If you want to tweet about these things, you can use hashtag Web Zurich as well. We want to share the love on Twitter, please do so. We also have a Web Zurich account on Twitter that you can tag. So for those of you who have been here before, you probably know this, but for those of you who haven't, what's Web Zurich? Generally speaking, normally when it's not online, we are a meetup for people who work with the web from the Zurich area. That means people who are building all sorts of different parts of a web experience that we all love and use, like designers, user experience experts, developers, accessibility experts, marketing folks, SEOs, content strategists, e-commerce experts, people who work with XR, people who build games on the web, security. It doesn't really matter what your background is. If you are contributing to making things on the web, then this is your home, and we are happy to have you. And maybe you also could submit a talk, because these meetups live from people submitting talks and sharing their ideas and experience here in this forum. We have a few principles. The most important one is everyone is welcome. You don't have to be a professional. You don't have to be a beginner. Everyone here can get something out of it, out of the experience of meeting others, building cool stuff on the web. And we want everyone to get together, share their ideas, share their struggles, share challenges that you are facing, work together, and just have fun. And we have a few people who do that in the Slack channels a few times. And then basically Web Zurich-driven development has become a thing. We do these meetups monthly, and we have been doing them in the last 4 or 5 years. And they are mostly in English. You can speak whatever language you're comfortable in, but it makes sense to try at least to speak English. I'm also not a native speaker. Try to speak English, because that allows other people to chime in and join as well. And this meetup is as much your meetup as it is our meetup. If you have any ideas, if you have suggestions, if you would like to see something happening in terms of talks, just ping us, let us know. We are happy to take your suggestions, and we'll see what we can build together. Oops, sorry. Generally, we do have a neutral home, but that's not really necessary for the online version. But normally, if we have in-person meetups, we are usually in the Impact Hub here in Zurich. Sweet. If you want to hang out with our community, the best point of contact is the Web Zurich website, which is the hub for pretty much everything that we've got. So previous talk videos, upcoming events, as well as pretty much anything else, links to all the different communities. You might join us in Slack, which is pretty fun. You can actually chat to lots of people. Yeah, there's an introduction channel where you can just introduce yourself and see who else is around. There's random stuff going on, and all sorts of more like structured conversations happen there as well. If you look for a new opportunity to work, or if you are trying to hire new people for your team, there's also a job channel that you can use to find people or to find opportunities. And then we publish these meetups on the Meetup group, as well as other events. Should we do workshops or something, those end up on our Meetup group. Again, as I said, this Meetup lives from the community as much as the community lives from these Meetups. There's 15-minute no Q&A talks. They are now easier than ever because you can just hang on to your favorite desk, chair, keyboard, mouse, screen, camera, and so on, because you have your home set up. It doesn't have to be a very fancy setup. Any kind of webcam that's built into your computer probably suffices. Microphones also usually are okay these days. Just let us know if you have an idea. Just submit it. Don't double take yourself. Just like basically go for it. We are happy to talk to you about it. And also, hi, Steve. I see that the chat is being used. Hi, Steve. Where from, Steve? Developer, front-end, back-end, designer. Tell us a little bit about yourself. And also the others who are silently watching, because I see that people are watching. Use the chat. Use the chat here on YouTube. Tell us where you're from, what your background is, and if this is your first Web Zurich maybe as well. This entire community would not be possible without a group of fantastic people who make all these things happen behind the screen. I am now in front of you on your screen, but that's the tiniest part of this community. All the work that happens in the background is done by Alexei, Daniel, Olga, Stuart, and Rob, and a little bit of me sometimes, very few moments where I need to do much, because pretty much the entire group is amazing, and I'm really, really grateful to work with them. They're all volunteering their time. And we have been volunteering our own money in the past as well, just to make things happen and make sure that this keeps running. And it wouldn't have been running for years at this point on a monthly basis if it wasn't for them. If you want to help us out a little bit, you can sponsor for real events. We usually take drink, snack sponsoring, but that's not really something that happens these days. Today's sponsors are Rockstar Recruiting. Again, if you are looking for new people for your team, or if you are interested in a new challenge, Rockstar is the people, or is the bunch of people to talk to. We have Valtech, which is software engineering consulting. And Graph CMS helps us by basically powering our website with their amazing CMS, headless CMS based on GraphQL. It's great. Again, if you want to join the conversation, you can use the chat. Please do use the chat. I see a few people are saying like, hi, Julian. Hi, Christian. Hi, Steve again. It's really cool to see that a bunch of people coming in from Switzerland, actually. That's lovely. First time. That's great. Welcome. Very happy to see first timers here every single time, as well as return folks, like people who come more than once. That's great. So the YouTube chat is one opportunity to, get in touch with us. The other opportunity would be to join Slack. You can do that on our Web Zurich website. And also after the talks are over, we will start a chat server using Jitsi on webzh.dev/afterparty. I'll show you that URL later on again. No need to worry right now. I'll let you know again afterwards where you can join the live chat. You can turn on your microphone and or camera and join others to just have a chat and have fun together. Yeah, there will be a next meetup next month, but before we jump into that part, let me actually stop sharing my screen and invite our first speaker to the stage. Hi, Pierre, how's it going?
Hi, I'm all right. Joining from an attic somewhere in Zurich. It's a bit cold, a bit chilly.
Yeah, it has gotten a little warmer these days, like we had, 7 degrees 2 days ago, and now it's like 15. It's not too bad.
Summer is coming.
That's optimistic. On the south half, southern hemisphere, that yes, but for us, I think it's winter is coming, unfortunately. You brought us a pretty cool topic this time.
Yeah. Should I just get started?
I think we can get started. So Patrick will introduce us to nominal type systems.
Patrick,
give a round of applause in the Patrick.
Pierre.
Sorry, I don't know. Pierre. Oh God, Pierre, how long do we know each other and I still am not good? This is the proof that I'm not good with names and faces.
It's all right, Mark. It's all right.
Yeah, Mark works. At least you didn't call me Morty, because a coworker of mine calls me Morty, but that's also fine. I guess that's okay. I can live with that. All right, I'll shut up and let you have the stage. Have fun.
Cheers. So tonight I will have a presentation called Nominal Type Systems. And I have recently learned about those. And I've actually been able to use them on a recent project. Nominal type systems could probably be explained within 5 minutes, assuming deeper knowledge of type systems and how their counterpart structural type systems function. This is why we'll first discuss type systems in general, programming languages, what types and values are, etc., etc. So I think there's going to be some for everyone. People who are already familiar with type systems will probably have some repetition in the beginning. Maybe you might learn something off even then. But people who are very new to programming or never used any typed languages will certainly learn something in the beginning. And in the end, probably on the last 4 or 5 minutes, we'll talk about nominal type systems. The thing is that I won't be able to do it in the 15 minutes. I have 88 slides. I already used 1 minute. So let's go. When we program, right? When we program, we usually use values. That's what programming is about: modifying values, having values, etc. And here we see a primitive value represented by a symbol, the symbol 1. In order to print out this value, or the value of this symbol, we can use a function, console log. And in my editor here, I have a little plugin that will, if I do console log anything, a variable or a primitive value, it will give me the result here. We'll be using that a lot throughout the presentation. So if we console log 1, we get 1 back. And if we look at the type of 1, which type of is a keyword which will return us the type, it will tell us it's a number. So types will represent kind of an abstract thing about the values we're talking about. We can look at text. If we look at the type of a text, it's called string. And to be honest, I tried to figure out why they're called string this afternoon. It took me 20 minutes and I gave up because every explanation is different. It would be a good talk, though, if someone wants to give a talk on that. We don't have just strings and numbers. We have booleans too. Booleans represent if something is true or false. And everything has a type. So we saw that we have this console. And if we look at the type of the console, it's an object. And the type of log itself, so here, is a function. Programming languages all have built-in data structures, which are of some type, and they mostly differ. So not every programming language will have the same types, but a language without types does not necessarily exist. Probably there's one, I don't know. So let's look at the types we have in ECMAScript, being the standard of JavaScript. The latest ECMAScript standard has 9 types, 6 data types. For example, the ones we saw before, booleans, undefined, etc., etc. To represent a number, for example, in JavaScript, we have 2 types, two data types, one being the number and one being big int. As we said, types differ depending on the language. So if we compare this to Rust, for example, Rust will have something called an integer type, which we usually think of as, in German, ganze Zahlen, so the mathematical integer, 1, 2, 3, 1 million, and minus 1 million. And they have a second type for numbers, floating point types. the floating point is often, at least I usually think of them as real numbers, where that's not actually true, because in math, pi, for example, which is a number that you cannot represent in computer, would be a real number. But it's good enough way to think about real numbers when you talk about floating points, until you have errors due to rounding. These data types, they represent a single value. They're not composed. So it's a value, which is a number or a text or whatever. Additionally, we will have in JavaScript or ECMAScript 2 structural types, one of them being the function. We saw that with console log. And objects. Objects can be thought of composed values, right? They are structured values. One example of an object could be an address. So if we look at how we could represent an address, we have a street, number, zip, city, etc. If we look at its type, it's an object. Strings and numbers. And I know there's a typo in all my slides. Let's just say it's number. So the number of the address is actually a type number, which actually it usually isn't, because it's a string. There's one more type in JavaScript, which is the structural root. I'm not going to get into it because, again, another talk for 20 minutes. So let's just jump ahead, ignore it. And until now, we saw some types, but we wanted to talk about nominal type systems. And in the word nominal type systems, or in the name, there is type systems. We saw types, but what's a type system? A type system is basically a set of rules with regard to types of languages, or of a specific language. So we have rules on how these types function, and all these rules together will be called a type system. And type systems come in different variants. We can categorize them. Among other categories, we can differentiate between static types and dynamic types, which we'll get into later. And we can also differentiate between nominal and structural. Structural being what we are usually used to with languages like TypeScript, and the nominal ones being what I actually want to talk about in the end. Well, now I'm losing my... Where am I going? So we could ask ourselves in what category of these differentiations JavaScript goes, because JavaScript obviously is our language of choice. JavaScript is a loosely typed language, and it is also a dynamic language. These two names, the words loosely typed and dynamically typed, are often used interchangeably, but they're not. They do not mean the same. You can have a dynamic language which is not loosely typed. I think Python, I'm not sure, but I think Python is a dynamic language which is not loosely typed. Let's look at what loosely typed means. When we talk about loosely typed languages, we talk about how the language reacts to different types being passed to operators, such as plus or minus or division, multiplication, etc. So if we sum or 1 with 1, we have 1 plus 1, it will return 2, which is what we expect. But if we sum 1 with the string 1, so the text is, then we get 11. And it's not 11, it's a string 11. So our logging here is not differentiating if it's a string or not, but it's returning a string, which is 1, which is then converted to the string 1, and they are put together, concatenated. This is makes probably more sense if we see what the plus is usually used for. In JavaScript, it's used to concatenate words as hello world. Loosely typed languages do convert automagically our types depending on the operators. It has to do with accepting compatible types. And yeah, I'm repeating myself. Now let's go to the part about dynamic languages, which often people, when they talk about loosely typed languages, they think they talk about dynamic languages. When we talk about dynamic languages, we're talking about how variables change over time, what types they contain, and how these types change over time. We are here declaring a new variable, which is called address, and we can assign an object to this address. A bit later, we can assign a string, and a bit later, we could assign a number, which could be an ID identifier, for example, from a database. In a dynamically typed language, a variable within one scope, within a function or any scope, can contain different types over time. You can see that as an advantage because you don't need to use a new variable if something changes over time, or you could accept different values as an address and then decide on how to compute on them. But they are usually also seen as a source of undetected errors. So the compiler or the editor will probably not see these errors. We will ship them, and it's probably going to take some time until we find them. One example being this address. I don't exactly know where I want to go with this. Oh yeah, exactly. So I assign the address to the variable address, and once I log it, instead of getting the address back, I get the string address object, and this is due to the fact that I forgot to remove the type of keyword here. Now, we said we have this category of dynamic versus static typing. So let's leave the dynamic languages where they are and look at static languages. TypeScript is such a language. So we can start the same as in JavaScript. We can just have initialize an address variable and pass it an object that represents an address. Over time, we can pass it a string, or we can pass it an ID, which means it's exactly the same as JavaScript. So it's typed. Shouldn't TypeScript help us with this? That was actually what I thought. The thing that happens here actually is that when we initialize the address variable, it is typed as any being a type that accepts any value. This can be changed, so we can make sure that the address variable will not accept any. We can tell it, dear address, you're a variable of type string. And once we pass it a string, nothing, all is good. But if we pass it an ID or an address, we will get an error. So what we did here, I'm slowing down 1 second. What we did here is that we explicitly assigned a type to a value. Explicitly means we write it down. We say address, you're of type string. Types can also be inferred. Not every language can do that. TypeScript does it very well. Inferred means that we have our initialization of variable. And at the moment we initialize it, we actually pass it a value. And now TypeScript, the compiler, knows this address is of type string. It's not of type any anymore. And if we try to assign an ID or anything else, it will render an error at compile time. It's also important to know that this is not a program. What we see here is not a program. If it was JavaScript, it would be a program, but given that this will not compile, the compiler will throw an error, we're actually just looking at a text file, not a program. So the variable now only accepts strings. This is a statically typed language. It means that the type of a variable does not change over time. Obviously, we could use the any type, which would make it look like a dynamic language, but we shouldn't do that. Again, this talk was about nominal type systems and not statically typed. So let's look at nominal type systems. Nominal type systems are opposed to structural type systems. And yeah, I think now I did something I shouldn't have done. We talked about statically typed languages until now, right? And nominal systems and structural type systems can be both static. TypeScript is a static language, which is structural. What does that mean? It means that if we have an address, a variable, for example, which has a type of string, we can assign it any string. So Rote Fabrik would work, Web Zurich would work, and this phone number, I hope doesn't belong to anyone, would work as well. So we basically need a new type to represent this address string, right? And in TypeScript, we have a keyword called type. We have different ways to define types, but one of them is type. And we can now define an address as follows. We say it's a type. It has street, number, zip, and city. Those are either strings or numbers. And then we can initialize our variable. We can tell it it's an address object. And once we assign a value to it, the compiler will warn us if we make an error. Now, we know that we can define types, good. Could this help us solve the previous problem we had with this address and the string? Could we define a new type that makes sure that when we get an address string, it's actually an address string and not a phone number or an error or whatever? So let's start by doing this. We take our type keyword. We define a new type called address string, and we tell it it's a string. We can then restrict the address variable to this new type. Address is now of type address string. And we could imagine that we have an API that's called get address string that returns an address string. Get API for get address string currently will return a string. But what we can do is that we can tell the function, we can tell the compiler that in this particular case, get address string will return an address string. And the compiler will actually see this. This is what you see when you hover in your IDE. And if we return something that's not compatible with an address string, we will get an error. We can then assign this address string to our variable. And all is good, right? We assigned it. We defined the type address string. We assigned it to the variable. All is good. And right now, if we assign a phone number, it should give us an error, which is what actually I assumed some month ago, and I noticed that no, in TypeScript this will not give you an error. My note says I should pause here, so I will pause, drink a little bit of water, and let you digest what I said until now. I'm way over time, but we're getting there. We're on slide 84 of 88, and then there's a little bit of live coding left. The reason TypeScript accepts a string as a so-called address string is that TypeScript is a structural type system. So it's a type system that will accept types as being equal if they have the same structure. If we take the example from the address object we had before, we could define a new type that's called Lieferadresse or Rechnungsadresse or whatever that has the same type, and we could pass it into a function that will expect just an address because it has the exact same structure, it has the same fields, and each field has the same type. And this contrasts with nominal type systems. As the name nominal might say, in nominal type systems, the name of the type is very important. Two values are of the same type if the name of their type is the same. In a nominal type system, the code we have here would fail. Why would we want this? Let's quickly look at an example where a nominal type system would save us from having a horrible error. And then we'll look at how in TypeScript we can mimic a type system, a nominal type system. And yes, let's start. I have to close my presentation. There's an escape button on the keyboard. I have some code here. We have basically, where should I start? We have a pay function. The pay function will take some parameters, an ID and an amount. And we have a getUser function. And the getUser function will get a user. So let's imagine that Anna and I went for lunch. I didn't have money with me. I forgot my phone. She paid for me, and I should return some money to her. So I get the user. I know how much I owe her, and I will pay. I will pay to Anna's ID and the amount. Now, the ID of the user here is a number, yet the pay function will accept an account ID. An account as a bank account ID. Let's refactor that to bank account ID. That makes more sense. And in JavaScript, this will not fail. If by any chance we actually use integers in our database to identify users and bank accounts, we could even go as bad that the payment will work, will go through, no error will be thrown, but it will go to the wrong bank account. This is why usually it's recommended to use UUIDs instead of integer IDs in your DB. This is not what we wanted to talk about. So we have a pay function that should accept the bank account ID, which is a number, and in TypeScript, this will not fail. This is why we'd like to have a nominal type system. There is a generic type. Generic type is basically a type. You could think of it as a type function. It's a type that will take variables and then return a new type. That you can get from the simply typed library. I will show you what this is later. But we get the nominal type. We remove our bank account ID, that was a number here, and we say that our bank account ID is now a nominal type. It will contain a number. Here you could have, for example, the structure of the address we had before. and it has the name account ID. How this is implemented behind is quite clever. The source is open source. You can look at it, but I wouldn't go into it right now. And now that we have this, oh, I should call it bank account ID. Now that we have this nominal bank account ID instead of just a number before, our code here will break because we get an ID, which is a number, we pass it in, and the pay function expects a bank account ID. In order to show you how this could work, we could have never refactor code live. We could have a get bank account ID function, which will go to the database and get the bank account ID. We can then assign it, and we can then assign it to the, it's called get account ID. And I have an error. Anyone? Oh, sorry. I'm an idiot. This is... So we get the user ID here, but we pass in the bank account ID into the pay function, and now happy. Here we go. This could make, like, you can imagine many cases where this can make sense. I recently, for a client, I had to import financial data from a bank, and I use nominal type systems to differentiate between the IBAN number of the debitor and the creditor, so that we would be certain that we use the correct IBAN number everywhere. This is it. I'm at 22 minutes. It's all I have for you. We saw that TypeScript is a structural type system, which means that the types that seem to be the same are considered the same. We learned that there is another category of type systems called nominal type systems, that the name matters there. And we saw that using a generic, we can mimic that nominal type system. The generic I used comes from a library called Simply Typed. Simply Types will offer you loads of generics that can help you in development. And all I have left to say is that I'm Pierre Spring. I'm a freelancer, Node front-end developer. I will probably be available for new contracts in February or March 2021. Thank you for your attention, and I hope you learned something useful tonight.
Awesome. Thank you so much, Pierre. We have actually one question if you are interested in answering it. It's Steve asks, Pierre, what is your opinion on type-safe programming languages versus dynamically typed programming languages?
Do you have an hour?
Oh my.
I would say there is lots of how do you say, what's the word I'm looking for? Misconceptions about typed languages. At least I got into it with misconceptions. I thought we will get rid of unit tests altogether. They will not help you find every error. I also thought that it will be super simple to get onboarded with TypeScript, and to be honest, you will lose productivity at least for a month or two getting there, because some things are just either you have bugs in TypeScript. In other languages, this wouldn't be a problem, but with TypeScript, I have, in the 20 years I'm coding, I learned that the compiler is right and I am wrong. With TypeScript, sometimes this is wrong, and it takes me a very, very long time to actually go and check if the compiler is wrong, because I assume I am wrong. So you will lose time, you will find bugs, especially with TypeScript. This being said, It's incredibly good. Once you're into it, you can just code. It's a different way of coding. You go in, you change your types, refactor until it's not read. Even in front end, you never go to the browser. You don't look at your stuff. I mean, as long as you do the JavaScript work. CSS is probably different. So you work much quicker. You're very confident. And I have shipped things that I didn't even test because stuff is not read, it's good. But it takes a while. You can't use a regular array filter to filter out different types. There are weird little things. I don't want to go back, though, without.
Awesome. I know exactly what you mean. I had just literally, I think yesterday, a scenario where I had an outdated types definition. And then like TypeScript was like, you can't do that. I'm like, I can.
Oh, the definitely typed is a catastrophe. So there is this. It's a catastrophe. It's wrong, but it helps you. But I mean, most libraries are still written in JavaScript. So what happened is that there is this project called Definitely Typed, where people can go in and just write type definitions for types for libraries. I, for example, had to use the tar stream library, where we got from the bank some tarred XML files and images, and only the most used 20% of the library were typed correctly, and everything else was typed but wrong. So you have to start using type hints. Type hints mean that you tell the compiler, do not check my code, and as soon as you use type hints, you're double effed, because you can change your code and you will never notice you have errors. And using a statically typed language, you trust your code and you will be less careful. So yeah, there are downsides. Still enjoying it anyway.
All right. Awesome. Pierre, it has been a pleasure. I hope to see you again in a future episode. I think you have done like 2 or 3 talks already at Web Zurich, and
this is my first.
Is this your first? You sure?
Yeah, we did the JS Zurich stuff, maybe.
Maybe. I don't know. It's confusing, but you have been a landmark of the local community. So good to have you here every single time.
Thank you. I hope you learned something. I hope it was interesting.
I did. It was interesting. Awesome. Thanks a lot. And with that,